All right. So back into it. So some of them are going to have triangles already put together with parts of it known. The hard parts come when they don't give you the picture. So they just give you the parts that you know. Because drawing this gets a little bit unclear. Angle A is 43, so let's first draw A is 186.2. B is 284.6. And angle A is going to be down here. We're at the base of B, so B just has to be bigger, and then angle A is here. So angle A is 43.1, and B is 284.6. So the unknowns are C and B and little c. Yeah, big C, big B, little c. Yes. Not necessarily. I mean, again, that's definitely not the only way to draw this triangle. I just started drawing it. I know the A's got to be 186.2. I know B's got to connect to A. So I could have drawn B, little b here. I just know that they have to connect. Now, what angle they can, I don't know. And in fact, this is definitely not the only way to draw this.
So you could switch to B with G?
Oh, hell yeah. As long as A is this long, B is a little bit longer, they connect somewhere, and this angle is 43.1. Don't break out your protractors. Just give yourself some kind of a reference. Make sure this is not 90 degrees or something. All right. This is where the picture kind of is misleading, though. Once you draw that, you feel like that's it. You got all the stuff to worry about. Obviously, I told you that we're going to do an ambiguous case, a case where there's more than one answer. So that's going to have to come out in the math then. You're not going to have the picture tell you, oh, there's a whole other way to do this. So let's just start trying to do this problem. What ratio can I set up? What's my go-to ratio? Yeah, I know A and A, so that's good. So I can always set up sine 43.1 over 186.2. Now this is kind of neat. We haven't had this situation yet. I have B's length, but not B angle. So I have sine big B over 284.6. How we do so far? So you always want to find that fully known ratio, and then you can set up whatever other part known, part not known. All right, so let's see what happens here. And somebody remind me. Well, let's see what happens. Let me get there. This is not so bad. You multiply the 284.6 times this divided by this. Okay. What am I going to have to do, though, to solve for my angle? I can't divide this in a way. Sounds like a really freaky church experience. What do I have to do to both sides to kill that sign? Inverse sign. What do I do to one side to kill it? I do the opposite. Right? So whatever the hell that is, I got to take the inverse sign of it. Oops. So then this side I get B. I'll do that side. You guys do that side. 50-50.
65. 65.8.
What is it now?
65.86.
Ooh. Aw, poor little things. That's weird. Yeah, what do you guys get?
65.
Try this again. Yep.
So why did we invest it?
Weird. So you guys are getting an answer? What are you getting?
65.8.
Yeah, I know.
It's
It's
65.
Let's see what's going on here.
Sine inverse is 0.91.
We see 284.6 times sine of 43.1 divided by 186.2.
It's 0.912.
Oh, it comes out bigger than 1. That's interesting.
Maybe it's because it's almost 45 degrees and the other one's like almost double the other one.
No, it should come out. You see. So this is what they give me here.
It's 0.912 sine.
What's that?
Be quiet. Let's see. Which one was this? This is- There.
Yeah, Eric domain too. I did too.
280. Oh, I see. All right.
Did you mess up? Waller did it wrong. You did.
Oh, come on.
Oh.
Now you guys,
Oh.
you guys
Oh.
should be helping me out with.
Should have known it was
Ah.
48.
Ah.
Should have known it was
Yeah,
48.
yeah, yeah. That's so funny.
Oh.
I like that you all trust me so much that nobody checked me against the book. I like it. So, real quick, if you do, now listen.
Okay.
Now, I knew there was a problem because it come out the math error, and that's not going to happen. The problem is if you do just that by itself, when I had the 284.6, it came out bigger than 1. Why is that a problem? Because the output of sine can't be bigger than 1, so the input of inverse sine can't be bigger than 1. So I knew there was a problem somewhere. First thing I should have done is what I normally do when I tutor people is look in the book. So I'm trying to tutor myself. I wrote the problem down wrong. My fault. But you guys kind of double check. So what do you guys, now we should get to 0.9.
65.8.
Oh yeah, so in degrees, what do you get, 65.81
81.
degrees? Cool. 81? 82? Certainly. 82, yeah. Alright,
How many sixes?
so now I know B.
And you know C, and you know last side.
Sig figs, it's my chemistry.
I mean,
Sig
how many
figs.
digits do you want us to
Sig
go to?
figs.
When in doubt, go a couple places. They only go out one place on all their stuff, so. Yeah. If you want to do sig figs, I'll let you do that. You can worry about it.
Oh. Bad habit,
I know.
that's my baby.
So now we just have to set up the other ratio. But the problem with this is this could be 65.82 degrees. But remember, what happens when you take an inverse sine? What's the output of an inverse sine? What's the range of inverse sine?
What's this, like, negative? What?
Negative.
What?
Actually, let me be less specific. When you have an inverse sine, are you getting the angle that you might actually need? You're getting or a reference type angle, right? Because it can't give us all the angles in all 4 quadrants. It only gives us the angles in 2 of the quadrants. So this could be 65.82. Or, careful.
No,
I need to be in another place
plus-
where
plus 90.
y is positive.
155.
Or 180 minus this.
Yeah.
Or 114 point.
Yeah.
Sucks.
What is it?
114.
114. point 18.
Yep.
So it could be this or that.
Yeah, or that. The only time that this could happen is in this case, and this case, what did they give me originally? They gave me these side angle. So it's the side angle case that could lead us to
This or that.
bad things. And it's kind of nice to remember, if you think about it the other way around, that's the one situation that could be a real ass and put a kink in things. Right? So that's the situation where I gotta be careful. That's where I gotta check. Now right there, does this angle work with the other known angle?
Yes.
Like if this known angle was 90 degree, or let's say 95 degrees, they wouldn't work with that because right there that's more than 180. Then I know there's no second case. But that does work with this. Oh shit. There's probably a second case. So what you're going to love about this problem is you have to finish out if it's this, and then you have to finish out if it's this. You have to get everything. Scheiße.
Yeah, but this one.
I think
Okay.
it should be 65.
So it could be this. That's case one. Or B could be 114. Oh, let me see. I don't know what that is. Be this big thing. Yeah, there. This big angle, 114. Ooh, that's kind of gross. So this could be 114.18. I want to put everything back on here that I know. There you go. So I want to finish this triangle out, and then I have to also finish this triangle out, so I cover both bases. So again, they're both possible answers. And why is this not a big deal? Because we've had equations with more than one answer, right? So certainly, this is another kind of equation. It can have more than one answer. It just happens to relate to something geometric. So if I want a rectangle that's got 90, an area 90, don't I have many, many ways to do that? Not just 9 and 10. You with me? If I want an area 90, it could be 3 and 30. Right? So here I need a triangle that has these things true about it. That's not enough to make it one possible triangle. There's two possible triangles. Okay, so let's finish this one out. What else do I still need to know in this here? This is case one. So I still have C, and we know C is 180 minus this stuff. Let's see, what is that? 0.92, so 71.08. Sorry? Everybody with me? Once we get two angles, we got 3. And then anything else we still need? We still need C, right? And what can I use to get C? Can I? Not a right triangle. Alright, so I have to use law of sines. So again, I use the 43.1 over 186.2. I go back to my known thing that I definitely know those are right, because that was given to me. Equals sine of 71.08 divided by little c, and then solve for little c. Was it 257? Now I am not looking forward to. I am not the neatest person in the world, so I would hate to have me as a student. But I know some of you guys are going to be even worse than me with this stuff. So there's two cases. You have got to make sure I understand what's what. But just have these angles out of nowhere, and then, well, you can tell which ones go to. No, you put them together. So what about the second case here? Yeah, same thing. So now I just got to start with this picture, and I don't know. This was what was this? This is B. B. I still don't know little c. And what's this angle here going to be? What's angle C going to be now?
Oh, 22.72.
22.72.
Yeah.
That's this plus this. Take away from 180.
Yeah.
Yeah. Okay, that's good. So now I can set up the ratio. It's not that much extra work. So the last ratio I have to set up there for case 2, where angle B is 114.18. I can set up, I can start again with this one. The one that I know is definitely good. Sine 43.1 over 186.2 equals sine of the new C here, 22.72 over the unknown C sine. Okay, cool. And then whatever the hell that comes out to. So 105.25. Cool. Yeah.
Is that for low times?
Say again, sorry?
Is that for low times?
This here? Yes. So again, we got this directly from what they gave us, or it could be this. Because when I do an inverse sine, it gives me reference angles. It doesn't give me the actual every possible angle, so I have to be careful. I got to check both out. Some of these are going to come out where this angle couldn't possibly work. Awesome. You have no second case. Some of them are going to come out where this angle didn't even work. Awesome. You have no case. There's no solution. Because if I wanted a triangle that had this side, this angle, and this length, that's never going to work. You guys see that? So they could certainly give me pieces that don't go together. So it's just like equations. I could have more than one solution, or no solution. Just like solving equations. Okay. So like anything, when you look at the board after it's done, it looks heinous as hell. But you guys, I think, are picking up. This is just ratios we're making. It's not. This isn't that difficult. The easiest mistake, of course, is to forget to check this. Okay. So it's this case here, SSA. They give me two sides and one angle. That's where I could get into trouble. That's where you have to be careful about two cases. If it's not this case, you're good. You don't have to do the one case. It's only going to be one case.
Is that rule one of them out, or are we still working on that?
What's that?
Is what we just did rule one of them out, or are we still working on it?
So we finished both triangles, right? We got C is 105.25. So we got all three angles and all three sides for both cases. The ruling out would happen right here. If this other possibility was like 170 degrees, and the angle that we already have is 43, those can't work. So I wouldn't even have to try to do the second case. That angle works. I have to do both cases then. Cool. So one triangle was like this maybe, and the other triangle is where this pulls in. Like that. So it's still the same length, it just pulls in to there. And again, the book does a better job of showing you that it swings over until it fits in again. Because this angle has to be this. So it's only that ass situation, yes. Taking care of the, that's not the word. Be careful with the ass situation. Okay. So last thing I want to do today. Cosines. So we got the one from here? More than you ever wanted? So I can sense that we, guys, we all desperately want a derivation of this law of cosine. So I'm going to give it to you. but it doesn't work for every situation, so I need something to fill it in. Law of sines is easy. It's ratios. It's easy, but it sometimes leads to that ambiguous case. So the work is easy, but the concept is weird sometimes. You got to be careful about the ambiguous case. Here, the equations are uglier, but there's no ambiguous cases. Plus, law of sines only works for certain triangles. Law of cosines works for the other types of triangles. So together they can handle every triangle.
What section is
Yeah.
this?
Captain Planet.
Yeah.
Captain? What's that?
What section?
6-6. That's funny. So I'm gonna do something like the book does. Where's my little paper? Here it is. So let me see if I can make this make some sense. All right. So stay with me now. The idea with Pythagorean theorem is, given these a right triangle, I can piece those together to get that last side. So it's all about the length of this last side. You with me? Okay, so far so good. Nothing amazing there. This triangle kind of sucks, and the reason I put it onto a really rough coordinate plane is so I can really focus on the idea. The idea is the length of that last side. This angle, though, is not 90, so I can't use Pythagorean theorem directly. To get to the equation that we're going to use, we're going to do something that you never have to do. It's just the derivation. It tells me why the equation is the way it is. So we're going to get this length of this the hard way. We're going to use the distance formula. So let me see if you guys are up with this. What point is that? What point is that? Nothing major, nothing hard.
1, 0.
X.
I like it, but no.
X axis.
Zero.
Almost.
X,
Too high.
How long is this?
X.
A. I already denoted it, right? That's the length of that side. Yeah, so I put it so that that's at the 0 mark. So what point is this? A. 0. All right. Now that was the easy point. Okay? That was the easy point. Because what the hell point is this? It's going to need some more room here.
C.
A.
Not quite.
Minus C.
Negative 1.
No, minus
C is up here. I
Minus.
need this, comma, this.
Minus.
X, comma,
So remember, this angle here is C, right?
Yeah.
So don't I have, let me see, let me get you guys with me. The
Cosine.
Y piece,
Cosine something. Cosine.
okay, you're with me? This Y piece is going to be related to the what function of this angle? If you guys aren't. Let me help you out. This is a right triangle, is that cool? Because this is directly up and down from there. That's the Y and this is the X, so that's at right angles. If this is C, I hate doing this.
100 minus.
If this is C, what's this?
100. 100.
I don't want to do that, do I?
Pi
I really
minus
don't want to do that.
180 minus C.
Let's see if you guys can come with me.
Pi minus C.
How can I say this so you'll be with me? Sure, I'll just tell you. This is B cosine C.
What? That's
So think about it. That's not right?
Is that angle A or angle C?
Where? This is angle A here.
Why is
That's
there-
angle C here.
Why is there a C on top of
Oh, that's my parenthesis for the point. It's a big ass parenthesis because it's going to take some room.
that?
All right.
Oh, I see. It's why don't I?
So now stay with me now. Here, let me break this down. Here is that side. Here's B here, right?
Yeah.
Here's angle C. Now if I do sine of C, and remember the unit circle. Wherever I am, sine is the Y piece. Cosine is the X piece, right?
Yeah.
So isn't cosine of C gonna be this side over B? Yes.
Yes.
Let me try again. Here, cosine of C, and this is B here. Just took it right off of there. Cosine of C is going to be B over the X piece. I'm sorry, X over the B piece. Okay. Right, the X over the hypotenuse? You guys with me? Because cosine gives me the X part. We just happen to be back in the second quadrant, but it's still going to give me the X part. So remember, when we first did trig, we were over here, and I was saying, here it's going to be all 1, 0, it's going to be all X. Here the X kind of shrinks a little bit. We just never really took a step back here because we really didn't have to until now. It's just going to be, the X is going to be the negative of what it would have been over there. But it's still going to be cosine of C. C is going to be bigger than 90. Are you with me? So shouldn't this be negative? And isn't cosine of an angle bigger than 90? Is that going to be negative because it's back in the second quadrant? So nothing new here at all. Cosine gives me the X piece. Sine gives me the Y piece. Yes, ma'am.
How does it give you the X piece if it's that angle, it's not that?
All right, so we're still stuck on the fact that there's a triangle sitting there. I understand that. But when we first started talking about the unit circle,
Yeah.
right? Tell you it's a circle. That's always 1. And the cosine gives me this piece, and the sine gives me this piece, right? No matter where the hell I am. Say again?